Hello and welcome to Newtonian Physics Part 3. This time introducing two more fundamental important concepts, work and energy. Okay, first of all, work. Work is what you do when you apply a force to an object which then moves in the direction of that force. This poor guy pushing this blue ball up this slope, for example, is doing work. He's expending energy. It's a hard thing to do, to push a heavy ball up a slope. It feels difficult. It's draining. He's going to get tired. And he's getting tired because he's losing energy. Energy is what he loses in order to do the work on the ball. We can quantify those ideas. Work is force times the distance. The product of the force that you're expending times the distance through which the object is moving. It's measured in a unit called joules. Now that's the work that's being done. In order to do that work, you're getting tired. You're getting tired because you're losing energy. And there's a fundamental principle in physics called conservation of energy. Energy cannot disappear. So if you're losing energy while you're doing this work, that energy must go somewhere. And it goes to the object that you're doing the work on. In the case we've just seen, the energy is going to the big blue ball. How can a big blue ball have energy? Well, a big blue ball has energy by virtue of the fact of where it is. There are two types of energy. Potential energy, which is energy that an object has by virtue of where it is, and kinetic energy, which is energy that a body has by virtue of how fast it's going. If I push a blue ball up a slope or lift a mobile phone up, I am doing work. The mobile phone is gaining energy due to where it is. It is higher up now than it was down there. That means that it has gained energy, potential energy, energy due to the fact of where it is. The higher you are away from the Earth, the more potential energy you have, within reason. I mean, if you went off into outer space and you were weightless, then you wouldn't have any potential energy at all. So, provided you're sort of reasonably close to the Earth, then if you move away from the Earth, you are gaining in potential energy. Kinetic energy, on the other hand, is energy that a body has by virtue of the fact that it's moving. You could imagine a force being exerted on a body. That force would produce an acceleration. That acceleration would change the velocity. If I push an object along my arm, it's the same distance away from the Earth all the time. So it's not gaining in potential energy. But if I exert a force on it, it starts to move. It's gaining in kinetic energy. Energy that it has by virtue of the fact that it's moving. And that's where the energy that I'm losing by doing the work on it is going. In the case of the water wheel in the picture, the water is losing potential energy as it goes from a higher place to a lower place, and that energy is going into the kinetic energy of rotating and accelerating this water wheel. For those of you who've done a bit of physics before, you will realise that I'm neglecting the effect of friction in all of this. I want to keep things simple for now. Let's put a bit of maths into this. If I'm lifting things up, then the weight of an object is given by its mass times g. It's called the acceleration due to gravity. So if I'm balancing a phone on my hand, then in order to stop the phone going down, I've got to produce an equal and opposite force on the phone. The phone is exerting a force down on my hand. That's just the weight of the phone. And I'm exerting a force up on the phone, which is equal and opposite, and that's why the phone isn't moving. Two balanced forces on it, weight and the force of my hand going up. Now, if I move the phone up to there, then I am doing work. The force that I'm exerting on the phone is the weight of the phone, and that's just the mass times g, the acceleration due to gravity. So that's the force. The distance through which I've moved the phone, we'll call that h. If I move it from here up to here, a distance h, then I am exerting a force of mg over a distance h. That means that the work that I've just done, which is the force times the distance, is mgh. Now, if that's the work that I've done, that energy that I've just lost must have gone somewhere, and it's gone to the potential energy of the phone. It has increased its potential energy by, well, it must have increased its potential energy by mgh, because that's the amount of energy that I've just lost by doing the work, and energy is conserved. So the phone must have increased its energy by mgh. Now that is the formula that we can use to work out how much potential energy an object has. Potential energy, mgh. The mass times the acceleration due to gravity times h, the height. Now, supposing after I lift it up, I dropped it. I won't drop it, it's my phone. But if I did, then the force due to gravity, the weight, would be acting on the phone, pushing it back down again. If we have a force pushing the phone back down, then by Newton's second law, that would be equal to the mass times the acceleration. Now, if it starts motionless, and it has an acceleration of a, then you may know this formula. The velocity squared is equal to the initial velocity when I let it go, plus 2 times the acceleration times the distance that it has travelled through. I won't go through the derivation of that formula. It's one of the 4 equations of motion when a body has a constant acceleration. What it tells us is what the velocity is going to be given the initial velocity, the acceleration, and the distance that the body has travelled. Well, if I just drop it from a standing position, then the initial velocity, u, would be 0. So the final velocity, v squared, is 2 times the acceleration times h, the height that it's gone through. What's the acceleration? Well, the acceleration we can get from Newton's second law. The acceleration would be the force divided by the mass. The force is the weight of the object. The weight of the object is the mass of the object times little g. We call it the acceleration due to gravity. Weight divided by m, the m's cancel, the acceleration is just little g, the acceleration due to gravity, and you can perhaps now see why that constant is called the acceleration due to gravity. It is the acceleration that a body would have if you just let it fall. So that's my acceleration. 2gh must be equal to v squared. Okay, if I take this formula and multiply it by m and divide it by 2 on both sides, I get this. Now, that is the potential energy that I've just lost. So that must be equal to the kinetic energy that the mobile phone has just gained. Therefore, this is the kinetic energy that the mobile phone has just gained. And that gives us a formula for kinetic energy. A half mv squared. So we now can work out both the potential energy and the kinetic energy of an object. That is the potential energy, and that is the kinetic energy. Okay, that's all I need to say about energy and work in Newtonian physics. Next time we'll see how these concepts apply to a system of hydraulics, fluids going around pipes.